Okay, for each of these problems, you're finding the area bounded by the x-axis down here, and then whatever else it's giving you. In this case, it gives you this curve, e to the 2x, x equals 0, and x equals 1. So we're finding that orange area. And the way you're going to do that is by doing an integral. And it's going to be a definite integral. So that definite integral will be from 0 to 1 of e to the 2x dx. The antiderivative of e to the 2x is going to be 1/2 e to the 2x. And in this case, we don't need that c because we're going to be evaluating. So we're going to go from 0 to 1. And that will look like, we just plug in 1/2 e to the 2 times 1 minus 1/2 e to the 2 times 0. Well, anything to the 0 is just a half. Or sorry, it's just 1, so this is going to be a half. And then over here we're going to have 1/2 e to the 2. And this right here is going to be your exact answer. We can get the exact decimal, but this one had an exact answer, so not asking for that from Desmos. Here you go. So we get about 3 2/10, but the exact answer you'd want 1/2 e squared minus 1/2, or if you wanted to factor that out, you could totally say 1/2 e squared minus 1. Okay, let's move on to B. Okay, in this case, we're going to do the integral from 2 to 4 of 2 over x dx, and that is going to get us the natural log of x evaluated at, 2 times the natural log of x from 2 to 4. So we'd throw in 2, and then natural log of 4 minus the natural log of 2, which, oh, come on. Okay, there we go. There's our answer. Here we've got our exact answer, or just Desmos doing it, and here is the exact answer. So that area right there is about 1.3839, I guess. Okay, and for C, we've got this function, and we want from 3 to 4, so it's going to be that little orange region there, and isn't that a fun discontinuous function? Exciting. For this one, we're actually going to need u substitution, but it's okay. Let's go through it. We're going to have the integral of x, and I'm actually just going to start out by saying x squared minus 5 to the 1/2 dx from 3 to 4. And I'm going to make this whole part u. So we're going to say u is equal to x squared minus 5 du dx is 2x. Dx is going to be the same as du over 2x. So then back here we'd get the integral from 3 to 4 of x to the 1/2 d. Hang on. Getting ahead of myself here. Here's u. Make it green. And then du over 2x. Those x's are going to simplify, and we're going to get a coefficient of 1/2. And then with the 1/2, we'd have u to the 3/2 over 3/2 evaluated at 3 and 4. Give myself a little bit more space here. So then we'd have 1/2 times 2/3 u to the 3/2. But u, in this case, we can get rid of that, and we can write x squared minus 5, and we're going to value it at 3 and 4. This guy will simplify, and we're just going to get 1/3 4 squared minus 5 to the 3/2 minus 1/3 3 squared minus 5 to the 3/2, and that will get us about 9.49. Cool. Let me know what questions you got. Okay, so we've got a u substitution and all sorts of fun stuff happening here. So here's our u. We're going to let u equal x squared plus 2 du dx would give us 2x, which means that dx is going to be the same as du over 2x. So then we can rewrite this as the integral from 1 to 4 of x over u times du over 2x. Those x's will simplify to 1, and we get 1/2 ln of u evaluated from 1 to 4. So let's then replace the u. We would get 1/2 ln of x squared plus 2 evaluated from 1 to 4. Okie doke. So then we have 1/2 ln of 4 squared plus 2 minus 1/2 ln of 1 squared plus 2. We can pull that 1/2 all the way out front, and we would get the natural log of, this would be 16, and 2 is 18, minus the natural log of 3. And then the way that we're going to get to that 6 is you're going to remember some log rules, and notice that if you have logs and they are at the same base, that you can write these as 1/2 natural log of 18 over 3, which is the same as 1/2 natural log of 6. Well, let me know what questions you have.